right. Good Monday to all of my honors geometry students. This is Mrs. Conway, and sorry I couldn't be with you today. However, I decided to go ahead and record the flip chart so that you're still able to get the lesson and while I was out. So at any time, if the sub needs to pause this video, just feel free to press the pause button there at the bottom of the screen, and that way you will be able to catch up if you need to on notes. So we are starting Unit 4, specifically Section 4.1 in your textbook, and we're going to be talking a lot about congruence in this unit, at least in the first part of the unit. And today we're specifically focusing on polygon congruence. So we are looking at how we determine polygons are congruent. So here in this picture you have polygon 1 and polygon 2. And these two polygons do happen to be congruent, but the question is, how can we determine if they were congruent without actually having to move them around? Because you could swing the two around, and you'll be seeing that demonstration a little bit later. What kind of things are you going to need to know? So that's what we're going to be exploring in this section. Not a whole lot you need to write. Again, I'll be letting you know if there are things you don't need to write and things you do need to write. But really, there's not much on this page. Really, it's going to be coming in the next couple of pages. So naming polygons. How do we name a polygon? Well, when we name a polygon, the rule is to basically go around the figure, and you can either go clockwise or you can go counterclockwise, and list the vertices as they come in the order. It doesn't matter which vertex you start with first. Typically, you're going to see starting with the first letter of the alphabet, and in this figure, that first letter happens to be A. So we are actually going to talk about all of the possible names for this hexagon. Hexagon having 6 sides, and of course, meaning that it has 6 vertices. Okay, so let's go ahead and start with the first very most basic one, which is starting with A. And if we start with A and we go in a clockwise order, we will get A, B, C, D, E, and F. So that is where you see A, B, C, D, E, and F coming from. And now if we start with A and we go in a counterclockwise, we're going to get A, F, E, D, C, and B. So that is where you see A, F, E, D, C, and B. Now, in order to make sure that we are listing all of the possible names, we can then go to the next letter of the alphabet, go clockwise and counterclockwise. Go to C, then go to D, E, and finally F. And finally getting to that there are 12 possible names for the hexagon. And again, this is only naming, so not a huge issue, but it is something that we do have to be aware of and making sure that we are naming these polygons correctly. Again, if you'd like to pause this in order to catch up on the notes, please feel free to do so. But we are going to move on to the next page. Correspondence between sides and angles. So below here, you're going to see 2 trapezoids. We have trapezoid A, B, C, and D. And finally, we have over here trapezoid E, F, G, and H. Now, I do realize that I went in a different order when I named them. That's fine. And I did actually name these in the specific way. And you'll see that in just a second. So when we talk about correspondence, it's a good vocabulary word, correspondence, the correspondence between parts that are basically congruent in the figures. So if you look at both of these trapezoids, and I take the one trapezoid and I basically try to overlay it on top of the other trapezoid, it doesn't look like they quite line up. Well, that's because you don't always just have to slide it. Sometimes you actually have to flip it. So we are actually going to take and we are going to flip this trapezoid horizontally, and it actually went ahead and created a second copy, so we don't need both of those copies, but as you can see, it basically mirrored it over the horizontal, and now if we put that one over top, you can see how they line up perfectly. There was our original trapezoid, and when we flipped it, we now have a correspondence. So now, if we were to write a correspondence between the sides and the angles, we are first going to look at a correspondence between angles. So here's angle E, and notice that that is corresponding to angle A. And since, of course, these are congruent, we're going to write a congruence statement. So these are called congruence statements. Okay, so the first congruent statement is going to be between A and E. So I'm going to say that angle A is congruent to angle E. Then I can go to the next one, and angle B is congruent to angle F. And angle C is congruent to, yes, you may have guessed it, angle G. Sorry about that pause there. And then finally, angle D is congruent to angle H. Now, I want you to notice something. Trapezoid ABCD is congruent to trapezoid EFGH. Notice by just the way that I listed the order of the letters, I can tell what the correspondence is, okay, and what the parts that are congruent. Now I can do the same thing with the segments. So, of course, in this figure, we have segment AB, and that is congruent to segment EF. So I would literally say segment AB is congruent to segment EF. And segment BC, right here, here's BC, is congruent to segment FG. And if it's kind of hard to tell, this actually, oops, sorry about that, that this letter is actually a G. I know it might be a little bit hard to see, but that is a G. It is corresponding to angle C as well. So the next one is that line segment CD is congruent to line segment GH. And finally, line segment AD. Oh, all right, let me go over here. Line segment AD is congruent to line segment EH. And again, listing those parts that are corresponding in the order. If you need to pause this, you may go ahead and do so now, but I'm going to move on. All right, so looking at these two polygons here at the right, we can tell what is corresponding and congruent by the number of what we call these tick marks. Yes, I did say tick, T-I-C. This is 1 tick mark, 2 tick marks, 3 tick marks, and 4 tick marks. So I'm going to look for that same number over here. So the 1 tick mark will correspond with the other 1 tick mark. Therefore, I know that AB is congruent to EF. And I know that BC is congruent to FG. And I know that CD is congruent to GH. And I know that EH is congruent to AD. So therefore, corresponding-wise, A and E, notice we have the 1 tick mark in the angle, 2 tick marks here in the B and F, 3 tick marks for C and G, and 4 tick marks for D and H. So therefore, my congruent statement is that ABCD is congruent to EFGH. Now, if I wanted to take and move this figure, trace it on top of the other one, you would see how they lined up. Again, if you'd like to pause, you feel free to do so. So therefore, we now have what we call the polygon congruence postulate. How do we know when polygons are congruent? And so going through this lesson, it might kind of seem like, well, of course, that's true, and that's why this is a postulate. Of course, does not have to be proven. Only theorems really have to be proven. So 2 polygons are congruent. You need to write this. Very important to write this. 2 polygons are congruent if and only if there is a correspondence between their sides and angles such that each pair of corresponding angles is congruent and each pair of corresponding sides is congruent. So how many parts, if you're trying to prove that 2 quadrilaterals are congruent, how many parts do you have to prove congruent? So for a quadrilateral, how many parts do you have to prove congruent? The answer is 8 parts. You have 4 sides and you have 4 angles. So now you could probably figure it out for triangles, pentagons, hexagons, etc. Okay. Let's think about this question for a minute here at the bottom. Suppose that quadrilateral MNOP and QRST are congruent. List all of the pairs of corresponding sides and angles in the 2 polygons. Like I said, do you even really need a figure in order to list congruence? No, you do not. So just by the order of the letters, you can tell what is congruent. So M is congruent to Q. Angle M is congruent to angle Q. And then you go to the second one, and angle N is congruent to angle R. And then you have two more angles, and then you have the four segments. One segment would be MN is congruent to QR. And you have NO is congruent to RS. And again, you could list those four as well. Okay. This video will be posted to YouTube, and then I will be linking it on Edline. So if you need to see this video again, please feel free to go home and play it, and you can fill in your notes. Other than that, your sub will now pass you out the practice that needs to be finished by the end of class, and your homework is in your textbook, which was up on the board when you came in the room. Hope you guys have a great evening, and I will be, I guess not seeing you, but you will be hearing me tomorrow going over section 4.2.